Hello, everyone, and welcome to day 12 of Jamb Physics in 40 Days. The Jamb Physics in 40 Days is a series that is brought to you by Oyalen, where we believe that when you dedicate within 30 to 45 minutes of your time daily, you will be able to acquire all the necessary skills, all the tools you need that will help you ace Jamb Physics. So, peradventure, you are preparing for the Jamb exams, and of the subjects that you have selected to write, physics is one of them, then trust me, this video is just for you. So get ready as we go through it. We've been able to go through so many topics from day one till now, and you do not want to miss any one of those. So please check out the videos from day one up until this day 12, because in each videos we look at individual topics that are in the JAM syllabus, right, for physics, and we do well to explain them, give a crash course, and also solve multiple past questions on those topics, as well as give you some guide and tips that will help you solve such kind of questions better and always get the right answers every time you do it. So please check out the videos from day one up until this moment. You can't afford to miss any one of them. And also do not forget to share this video. You don't want to enjoy it alone, of course. So please share it amongst your friends that are also preparing for the exam, so that they too can get adequate preparation and do well to ace their JAM exams. We promise you, when you dedicate this time, you will definitely score 90 plus in your physics. So please give it the time, share it amongst your friends, like the video, and also don't forget to subscribe to the channel. We need you to subscribe, because as you subscribe, you are also helping us to be able to make more helpful content like this. So please hit the subscribe button and also click the notification bell icon, so that when the next content is released, you will also be alerted. Now, day 12 is about temperature and its measurement. Now, for a better understanding of this topic, you can do well to check out our video on the channel where we explain temperature and its measurement in more detail. But for the purpose of preparation for JAM, we're going to be looking at what JAM expects of you as a candidate preparing to write the exam, especially with this topic. So what JAMB expects is listed here. We have that they expect that you should be able to understand the concept of temperature. That is, be able to define temperature, not just as the degree of hotness or coldness of a body, but from the aspect of the kinetic molecular theory. That is, you should be able to explain that temperature is actually the average kinetic energy possessed by the molecules of a substance. Right. So that would be a better way to define what temperature is. And beyond that, they also expect that you should be able to understand what is called the thermometric properties of thermometric substances. Now, you see, thermometric substances are those substances that have a predictable way that they react, that they have physical changes that are predictable with rising temperature. That is, as temperature is either increasing or decreasing, they behave in a predictable manner, right? So we now use this their property to use them to tell temperature. You can use them to measure temperature accurately. Now, some of these thermometric substances are in the case of your liquid in glass thermometers, where we have substances such as alcohol or mercury, which expand uniformly with change in temperature. We also have the gas thermometer, which relies on the pressure law. According to gas laws, the pressure laws, where you keep the volume constant and then the pressure changes uniformly with increasing temperature. We also have other types of thermometric substances, like the ones in the thermocouple that relies on resistance and voltages, like the ones in your pyrometers and the like, and even the bimetallic strip. So do well to check it out in detail so that you can get a fuller understanding, be able to list those thermometric substances and their specific properties. You should also understand the calibration of a thermometer, such as what are the properties or what is expected of someone who is building a thermometer. What are the characteristics that you should see in a working thermometer, such as the bulb, the kinks, and things like that. So you should be able to understand what those concepts means. And beyond that, you should also know what temperature scales are. Now, when it comes to temperature scales, I say this a lot. what really matters is that you understand what is known as the upper limit of a temperature scale and the lower limit of a temperature scale. Now, for Jamb, the kind of temperature scales that we work with most of the time is the Celsius scale. We also work with the Kelvin or absolute temperature scale. Now, take note, this Kelvin scale is also called the absolute temperature, and then the Fahrenheit scale. Now, these are the three majorly used temperature scales that we use as far as Jamb is concerned. There are other temperature scales such as the Rankine temperature scales and the likes, but we focus more on this. But your understanding of temperature scale should go beyond the Celsius scales. Like for instance, in the Celsius scale, we know that the upper limit, that is the temperature of pure boiling water rather. So let me correct that. The temperature of pure boiling water at 1 atmosphere, which is 760 millimeters of mercury, that would be 100 degrees Celsius as the upper scale. So let me note that here. Upper limit, then lower limit. So then in the Kelvin scale, that would be 327 Kelvin. Then for the Fahrenheit scale is 212 degrees Fahrenheit. Now the lower limit for the Celsius scale is 0 degrees Celsius. For the Kelvin scale is this is supposed to be 373. Pardon me, this is 373, so this will be 273 Kelvin. Pardon that error. And then for Fahrenheit scale, it is 32 degrees Fahrenheit. These are the limits of temperature, the upper limit and then the lower limit of these particular scales. Now, take note, it is beyond this. But you should understand beyond this. I will explain something when we get to this part though. But this helps you to be able to work with even unknown temperature scales. Now, let's get to types of thermometers. What Jamb expects is that you should be able to mention at least 3 to 4 types of thermometers, such as the liquid in glass thermometer, the gas thermometers, the optical thermometers, and so on like that. Be able to list different types of thermometers and also identify them based on their thermometric properties. Then finally, they expect that you should be able to convert from one scale of temperature to another. Now, many students are quick to memorize equations that help them to convert, for example, from Kelvin scale to Celsius scale, from Fahrenheit scale to Celsius scale, vice versa. But there's a simple trick that helps you to do this. Let's take, for example, we have two scales here. Let's call this part of the scale, let's call it the K scale, and let's call this the S scale. Now, they would both have their upper limit and lower limit, that is, their melting point and boiling point. Let's assume that the melting point in this case is A, and then the melting point here is B. Okay? Then let's say that the melting point here, for example, is C, and then the melting point here is D. The boiling point, I mean. Like if you're working with Celsius and Kelvin now, you know in this case, this will be 0, while this is 273. Then this will be 100, while this is 373. And if you were working with Fahrenheit to Celsius, for example, this will be 0 when this is 32. This will be 100 when this is 212. So once you've labeled this part, the next thing you want to do is now know the temperature you are converting to which. For example, if I'm converting from S to K, right? Now, if the temperature at S at this point is E, and I'm asked to find the value of the temperature, the corresponding temperature on the K scale. Now, let's call that the unknown X. What do you do in this case? Simple ratio will help you solve this. You just do E minus A over C minus A and equate that to the same thing on this K scale. So you have X minus B divided by D minus B. So applying this will help you to convert from any scale at all, not just from Celsius to Kelvin to Fahrenheit and the likes, but even from unknown scales, right? And especially when you are working with questions because Jamb likes to set this a lot, where they tell you there is a faulty thermometer which has, for example, the melting point at 2 degrees Celsius and the boiling point at 100 degrees Celsius, and they're asking you to find the real temperature when that faulty thermometer is reading, for example, 51 degrees Celsius. So you see, understanding this concept will help you convert easily, not just by memorizing formulas. However, if you are converting from Celsius to Kelvin, you should know that temperature in Celsius equals temperature in Kelvin minus 273, and then temperature in Kelvin equals temperature in Celsius plus 273. These are equations for Celsius and Kelvin. Now, if we are working with the Fahrenheit scale, now temperature in Celsius equals 5 over 9, temperature in Fahrenheit minus 32. And then on the other hand, temperature in Fahrenheit equals 9 over 5, temperature in Celsius, then plus 32. These are the common equations that we use to convert from Celsius to Kelvin, Kelvin to Celsius, Celsius to Fahrenheit, and vice versa. But beyond this, you should also understand this concept, because this is actually what forms these equations that we now know. So having gone through all of this, I think we can then go on now to begin to solve questions from Jamb on temperature and its measurement. And please don't forget to subscribe, and also you can check out the Exam Fund app. The link is going to be added in the description box. Click that link and download the app. The app is created in such a way that it makes your learning experience very much fun. So it has interactive game-like environment where you solve questions as though you were in a game show, and it makes the experience really interesting. And what is even more fun about it is that the more questions you get right, you win prizes that you can convert into actual cash. So please do download the app. Click the link in the description box that will take you to your preferred store, whether the Apple Store or the Google Play Store. Install the app, register, and have fun while you learn. So while you're at that, let's get our materials ready, and then let's solve some past questions on temperature and its measurement. Now, this question says a temperature 20 degrees Celsius is same as, and when we look at the options here, we see that all the options are in Fahrenheit. So it means that we have to convert this from Celsius to degrees Fahrenheit. So here's how we do that. So in cases like this, we can easily use the equation where temperature in Fahrenheit is 9 over 5, temperature in Celsius plus 32 degrees Fahrenheit. Now, when we apply this will mean that we have 9 over 5 multiplied by 20. Then we're going to add this to 32, and then our answer is in degrees Fahrenheit. Now, we see here that 5 goes here once, 5 goes here 4 times. And 4 times 9 would give us 36. So plus 32. And all of this in degrees Fahrenheit. Now when we add it up, what do we have there? That would be 68 degrees Fahrenheit. So the option to go for here is B. This question says, the temperature at which the water vapor present in the air saturates the air and begin to condense is known as. Now take note, condense means that it is turning back from its gaseous state into liquid state, right? So now let's look at the options that we have. Now, boiling point is the temperature at which the pressure in a particular phase is equal to the atmospheric pressure, such that it begins to turn into vapor. So that would be boiling point, and that does not match what we have here. Now, melting point is the temperature at which solids become liquid, but in this case we are looking at a gas becoming liquid, so this also doesn't match. Now, this triple point is a special kind of temperature at which all the conditions comes together that a particular substance can then begin to exist in all three phases of solid, liquid, and gas. So it also doesn't match this. That leaves us with dew point, which when we define is actually the temperature at which water vapor saturates the air and then begins to condense into liquid state. So the answer in this case is option D. This 1979 UTME question says, the height of mercury thread in a mercury in glass thermometer when in melting ice and then in steam are 3 centimeters and 18 centimeters respectively. So at a temperature of 60 degrees Celsius, the height would be, so and in this case you see that we're working with an unknown scale and we are comparing it with the Celsius scale. So let's put them side by side using this diagram. So where the top will be the boiling point is temperature in steam, of pure steam, and then this will be the temperature of pure melting ice. So for the ice, we have 3 centimeters as the length in thread, so 3 cm. While for the Celsius scale, that would be 0 degrees Celsius. That's the equivalent, right? And then for steam, we have this as 18 centimeters, while for the equivalent in the mercury in glass thermometer for a Celsius scale would be 100 degrees Celsius. Now we are trying to find the equivalent of 60 degrees Celsius for this. So let's call the unknown here x. So we apply the ratios. So it will be x minus 3 divided by 18 minus 3. And then we equate that to applying the same ratio on the Celsius side. We'll be having 60 minus 0 over 100 minus 0. Now what we have here is x minus 3 over 15 equals 60 over 100. So we can then say x minus 3 equals 15 times 60 all divided by 100. So we can then break this down. 20 goes here 5 times, 20 goes here 3 times. 5 here 1, 5 here 3. So x minus 3 equals 3 times 3, that is 9. Now this means that if we make x the subject, x will then be, on this side we have 9, then minus 3 crosses over to become plus 3. So x is therefore 12. And the unit here is centimeters, so that will be 12 centimeters. So from the options, that is option D. In this question, we're told the ice and steam point of mercury in glass thermometer of centigrade scale of uniform bore correspond respectively to 3 centimeters and 19 centimeter length of the mercury thread. So when the length is 12 centimeters, the temperature is. Now, fun fact, what we know as the centigrade scale was changed to the Celsius scales, I think in 1948, during the Conference of Weights and Measures. And the reason is because the word centigrade actually means grades of 100, which is a bit confusing because it's also used in other languages like in Spanish and so as the unit for measurement of other things even other than temperature. So to avoid confusion, it was then changed to Celsius to honor Anders Celsius, a Swedish astronomer who actually created a similar scale far back before then. So take note that when we see the centigrade scale, we are actually referring also to the Celsius scale, as long as we are discussing units of measuring temperature. So that's the reason why I gave that fact. So let's convert then. So what we're going to do is we're going to compare the length with what we know as the Celsius scale now. Now for the length at ice point, we have 3, and then that will correspond with 0 on the Celsius scale. And then what we have as 19 here will correspond to 100 here. And then we have to find that for 12. So when this is 12, what will be the value on the Celsius scale? So to apply this, the ratio would then be 12 minus 3 over 19 minus 3 equals x minus 0 over 100 minus 0. Which from here we're going to have 12 minus 3, that will give us 9 over, now 19 minus 3, that will give us 16. So this equals x over 100. So let's find the value of x. X therefore becomes 100 multiplied by 9, all divided by 16. So let's see what goes here. Um, Here 4 goes here 25, 4 here 4 times. So what we have left is x equals 25 times 9 divided by 4. Now 25 times 9 will give us 9 times 5 is 45, 5 carry the 4. 9 times 2 is 18. 18 plus 4, that will be 22. So we have 225 over what we have here is 4. So let's break it down. 4 will go in 22 5 times, remainder 2. And then in 25 it will go 6 times, remainder 1. So, and then we'll add 0 to that, that will be 2, 56.2, and so on like that. So when we compare what we have here, it will be approximately 56 degrees Celsius, which is in option C. The resistance of platinum wire at the ice and steam points are 0.75 ohms and 1.05 ohms respectively. Determine the temperature at which the resistance of the wire is 0.90 ohms. Now, before I go on to solve this question, if you are still not subscribed to the channel, what are you still doing? It's only going to take a second of your time. So please hit the subscribe button. When you subscribe, you are helping us to be able to make more helpful videos like this, and we want to keep making them. So please subscribe to the channel and also hit the notification bell icon so that you get alerted when we put out a new content for you. Now, to solve this question, we're also going to use the same comparative scales. So when we draw this, now remember that at ice point, when for the platinum resistance wire, we are having 0.75, on the Celsius scale, that will be 0. Now, and at the steam point, where on the platinum wire, we are having 1.05, on Celsius scale, that will be 100. Now, we are to find when it is 0.9. So we put 0.9 here, and then we try to find X, which would be the temperature on the Celsius scale. So let's convert. So this would be 0.90 minus 0.75 over 1.05 minus 0.75, and then we equate this to the difference here, which will be x minus 0 over 100 minus 0. Now this would give us 0.15 and 0.30 here, and then this would be x over 100. Now from here we can break this down to 1 over 2 equals x over 100. So what this implies is that x is 100 divided by 2, and that will give us 50. And since this is in degrees Celsius, the unit will be degrees Celsius. And that is what we have in option B. The melting point of naphthalene is 78 degrees Celsius. What is this temperature in the Kelvin scale? Now, naphthalene is a petroleum product that melts at 78 degrees Celsius. So in order to convert this to the Kelvin scale, this is what we do. Now, if you remember from the beginning of the video, I did mention some equations that you can try to know offhand if you don't want to use the temperature scales that we've been using ever since the previous questions we've been solving. So in this case, we are looking at from Celsius to Kelvin. So the temperature in Kelvin is what we're trying to find. And that would be temperature in Celsius plus the lower fixed point of a Kelvin scale, which is 273. And our answer, of course, will be in Kelvin. So we have here 78 plus 273. Now let's add. 8 plus 3, that's 11. So 1 carry the 1. Now 1 plus 7 is 8. 8 plus 7, that would give us 15. So 5 carry 1. Now 2 plus 1, that gives us 3. So 351 Kelvin. Now comparing with the options we have, that is option B. In this question, we are required to define temperature, right? Because the question says temperature is the measure of the, so we have to fill in that space. And at the beginning of the video, I did mention that you are expected to be able to define temperature not only as the degree of hotness or coldness of a body, but from the aspect of the molecular kinetic molecular theory, I mean. So, and I did define it then as the average kinetic energy of the molecules of an object. So let's look at the options and see which one tells us that the same thing. So in option A, we have the quantity of heat transferred into the molecules of an object. That does not define temperature. Now B says mean kinetic energy of the molecules of the body. Now another word for mean would be average. So it is similar to saying average kinetic energy of the molecules of the object, which is just what we defined as temperature. But when you look at the other options, we have kinetic energy of any individual molecules. Now, in this case, it has to be average kinetic, not the entire kinetic energy of each of the molecules, right? So, in this case, it is wrong also. And then D is looking at the amount of work done by the molecules of the object, which also does not define temperature. So, yes, the only correct one here is option B. The temperature gradient across a copper rod of thickness 0.02 meters maintained at two temperature junctions of 20 degrees Celsius and 80 degrees Celsius respectively is. Now, temperature gradient is the rate at which temperature changes between two distances, a stated distance rather. So, and if you look at what we have in the options, you see that the unit there is in Kelvin per meter. So normally we should convert this to Kelvin. However, if you're looking at difference in temperature, whether you are in Celsius or you are in Kelvin, you will still get the same difference in temperature because they both have a difference of 100 scales from the ice point to steam point. So if we convert it to Kelvin and still find the difference, we still get the same answer. So let's solve. So temp gradient is change in temperature or difference in temperature as in the difference rather in temperature. So let's make this difference instead. Difference, okay? Difference in temperature over thickness. So if we apply that, the difference in temperature would be now 80 minus 20 over, now the thickness is given as 0.02, right? So our answer will be in Kelvin per meter. Now when we consider this, what we have here is 60 here divided by, this can be written as 2 times 10 raised to power minus 2, right? So, and when we break this down, 60 divided by 2 would give us 30. So we have 30 times 10. Now this 2 becomes positive now when we change it to the positive index. So, and then writing this in standard form will mean we have 3.0 times 10 raised to power. Now 2 plus 1, that will be 3. So our answer is 3 times 10 raised to power 3 Kelvin per meter. So, and when we look at the options, don't get confused with these two. The difference is that this one is per meter cubed, while this one is per meter. So we'll go with option B. The quantity, or a quantity rather, of water at 0 degrees Celsius is heated to about 30 degrees Celsius. At each degree rise in temperature, its density will. Now, when we look at the relationship between density and rise in temperature, for every other substance, as the temperature increases, the density reduces. So they have an inverse relationship. So as temperature is rising, density drops or falls, right? But this is not the case with water because it has an unusual behavior, which is called the anomalous behavior of water. And what happens is that as you heat water from 0 degrees, what happens is that the temperature, the density rather, would rise from 0 to 4. Then it will then begin to fall back again. So because water is most dense at 4 degrees Celsius. So take note of that. The highest density of water is not at 0 degrees Celsius, but at 4 degrees Celsius. That's where it is most dense. So I'm not talking about ice, so please take note. I am talking about liquid water, right? So because you may get that confused and think that maybe 4 degrees Celsius water is more dense than ice. No, that is not what I mean. I mean when water is in its liquid state, which is between 0 to 100 degrees, it is most dense at 4 degrees Celsius. So having that in mind, we can then answer the question as option D. And it's a really fun thing because this is how nature actually preserves especially the aquatic species. Like in countries where it snows a lot, the fishes in the lakes and pools are able to survive the entire winter season because only the top part of the lake will be frozen during that season, and the temperature beneath that ice sheet you are seeing will still remain at 4 degrees Celsius, which is just enough for the aquatic life to survive. So our answer is option D. This question is one of those that many students often do not get immediately they read it. Like the question says, the thermometric substance of absolute thermometer is. Now, many students think that they just mean the absolute scale thermometer, and when they think of that, they keep their limits within the 273 Kelvin and 373 Kelvin. But in this case, we are looking at a thermometer that should be able to measure absolute temperature. Now, absolute temperature is 0 Kelvin. And when you convert this to degrees Celsius, that is negative 273 degrees Celsius. So which of these thermometric substances will be able to work for such a thermometer? We immediately know that mercury and platinum is out of it in this case. And the reason is that mercury itself freezes at negative 39 degrees Celsius. So meaning that once it gets to negative 39 degrees Celsius, mercury can no longer measure temperature. And this is why you see that in cold regions like in the cold parts of Alaska, the cold parts of Russia, the cold parts of Canada, and even at the Antarctic, as well as the North Pole, they use thermometers that do not contain mercury. They prefer the alcohol in glass thermometers in those kind of regions because it gets really cold in such places and the mercury would not work. So, and in the case of platinum, this actually works with the resistance of the platinum wire, which is perfect at standard temperature and pressure. So it wouldn't work at temperatures that are very much below the zeros as well. So we are left with alcohol and helium. Now, alcohol itself should be able to work, but the problem with alcohol is that it does not expand at the same rate well as you would expect with helium. Helium behaves better as an ideal gas. It's a noble gas, so it has the property of an ideal gas. And following the gas laws for when you have constant volume, helium will work very well. So use a gas thermometer with helium as its thermometric substance. So we use option C. Water is a poor thermometric substance because so let's look at the reason why water would be a poor thermometric substance. Now, option A says it's opaque. Now, this is wrong because water is actually transparent, not opaque. And opacity is supposed to be a property or a characteristics rather of a good thermometric substance. Take mercury for example, it is opaque and it makes it a good thermometric substance. So option A is not correct then. Now option B says a poor conductor. Now although water is actually a poor conductor, but it is not correct to this question in the sense that conductivity is not a characteristics to be considered when you are trying to pick a thermometric substance. So we do not consider conductivity in that case. So even though water is a poor conductor, this is not what makes it a poor thermometric substance. Now option C says wet glass, and yes, water does wet glass, and this means that if you use water as a thermometric substance, it will adhere to the glass and then will create a series of error when you are taking measurements. So yes, The answer in this case is C. But if we consider option D, it says has lower vapor pressure. This is wrong in the sense that water actually has a fairly high vapor pressure, and it's supposed to be a good characteristics also in this case. So the correct option in this case is option C. In this question, we have uh, four characteristics to consider. We have reproducibility, sensitivity, high thermal capacity, and high accuracy. And the question says the quality of a good thermometer include, and let's just look at these different qualities here and see which one actually works for a good thermometer. Now, when we say reproducibility, this refers to when a thermometer is able to give you the same measurement for the same condition. That is, if you use it multiple times for the same condition and it is always giving you the same measurement, that tells you you can trust whatsoever reading that the thermometer is giving you. So yes, reproducibility is a good quality for a good thermometer. Now, the second one is sensitivity. That is the ability to respond quickly to changes in temperature. And yes, you want your thermometer to immediately sense a change in temperature and give you the new temperature reading, right? So that will make this a quality of a good thermometer as well. Now, in the case of high thermal capacity, now when a substance has high thermal capacity, it means that it can absorb a high amount of heat. That is, it can take a large temperature change without it actually reacting to the difference in temperature. This will be a poor quality for a thermometer, because you don't want the thermometer to be responding slowly to temperature changes. You want it to be able to sense even the slightest change in temperature. So this would be unwanted for a good thermometer. And then the fourth one is high accuracy, and every instrument, not just thermometer, is required to have a high accuracy. That is, it should be able to give you a value that is very close, extremely close in fact, to the actual value. So the three qualities that we see here that would be for a good thermometer is 1, 2, and 4. And when we consider the options, that is in option A. So we go with option A. Now, in this question, we see that at the lower fixed point of a faulty thermometer is 2 degrees Celsius, while the upper fixed point is 100 degrees Celsius. And we are asked to find the true temperature when the faulty thermometer is reading 51 degrees Celsius. So let's solve. When you compare this to a working thermometer, you're going to have this as the ratios now. Now remember, it's reading 51, so we're going to do 51 minus 2 divided by, now the upper fixed point is 100, now minus 2 as well. And then we equate this to x over 100. Now this is x minus 0, which is still x, and then 100 minus 0 is still 100. Now for the numerator here, we're going to have 51 minus 2, that's 49, over, now the difference here is 98, and this equals x over 100. And of course 49 goes here once, 49 goes here twice. So now we have that x equals 100 multiplied by half. So the value of this temperature on a working thermometer would be 100 times half, which would give us 50. So the actual temperature is 50 degrees Celsius. That is in option B. Calculate the length which corresponds to a temperature of 20 degrees Celsius if the ice and steam points of an ungraded thermometer are 400 millimeters apart. Now you can pick your ice point or your steam point for this ungraded thermometer, but the key there is to ensure that they are 400 millimeters apart. So if your ice point is 0, your steam point has to be 400 millimeters. If your ice point is 100, then your steam point must be 500. Just ensure the difference between them is 400 millimeters. So now let's solve. So I'm going to keep my eyes point at 0 so that I don't get any confusion when I'm solving. So the unknown temperature will then be x, and x minus 0 will give me x over 400 minus 0, which is 400, equals, now this temperature is 20, so 20 minus 0 will give me 20 over 100 minus 0, that will give me 100. So x is therefore 400 multiplied by 20 all divided by 100. So 100 goes here once, and here it goes 4 times. So what we have is 4 multiplied by 20, which will give us 80 millimeters. So the correct option here is D. In this question, we are asked, the thermometer whose reading is indicated by a change in color of its thermometric substance is the, now the first one we have is bimetallic, this is C, so bimetallic strip thermometer. Now this one tells temperature due to thermal expansion of its metallic strips, right? So based on the way it expands with relations with temperature is how it's able to tell temperature change. So it has nothing to do with colors. Now for B, we have thermocouple. In this case, it is considering the voltage differences between the two couple that is used, the wires that are used for the couple. It measures the change in the potential difference at both ends to tell temperature. Now, for the platinum resistance thermometer, this focuses on the change in resistance of the platinum wire with its relationship with temperature. So this one does not also involve color. And then finally, we have the optical pyrometer, which is able to tell temperature even without coming into contact with the object you are measuring the temperature. It tells the temperature based on the color of the thermal radiation that is coming from the object that you are trying to measure its temperature. So you see there that it makes use of color change to indicate the temperature. So the correct one is option D. Now, to enable you practice more questions on temperature and its measurement, you can find the link in the description box that takes you to download the Exam Phone app. It's available on Google Play Store and also on the Apple Store. You'll find the link in the description box. When you click it, you'll be able to download the app and then have fun while you learn. Now, the interesting thing about the app is that it is built in like a game-like format, whereby you get to have fun in different levels of solving questions on your subject of choice. And not just the fun part, you can also earn as you learn. So please download the app by following the link in the description box of this video. And also don't forget to subscribe to the channel. We really need you all to be subscribed to the channel. So please click the subscription button and also the notification bell icon so that you get notified every time we put out a new content for you. And thank you very much for following this series. I'll be seeing you in the next video. Bye.